All right, so we are going to use the limit definition to find the area underneath this function from -2 to 1. So let's go ahead. Let's just draw a little sketch here to see what we got going on, and I'm intend for my pencil to break, but it's not an issue, no problem. Not my best graph. Okay, so this will be like a downward looking parabola. From -2 to 1 is probably something like, I think it's gonna not go all the way. It won't go, it'll get close, but it won't be all the way to like the edge. So we'll be looking at some areas sort of like this. And that'll be at 0.5, but that's not too important. So the area here will be equal to the limit as n goes to infinity of the Riemann sum, starting from I equals 1 to n, of f of c sub I times delta x. So our delta x, remember, is the width of our rectangles, and that's going to be equal to b minus a all over n. So our b is 1, our a is -2, so minus -2 over n. So it'll be 3 over n. Our c sub I, we could make it, any of the points in the ith rectangle. We'll just make it the right endpoint. That usually tends to be most convenient. So right endpoints. So c sub I, for the right endpoint, it'll be a plus I times delta x, where a is -2, plus I times delta x, which is 3 over n. So -2 plus 3i over n. I probably wrote that a little better. So this is what we're going to input into our function here. So let's actually so let's do our area down here so we can space it out. So we're going to take the Riemann sum, and what's gonna go here is our c sub I is this expression. And this will be what we're going to input into our function here. So it's going to be a little bit of algebra. So it'll be 5 minus c sub I squared. So 5 minus -2 plus 3i over n, that whole expression will be squared, times our delta x, which is 3 over n. So now we just got to make sure we do our algebra correctly. So rewriting the Riemann sum. So squaring this, so 5 minus, so -2 times -2 will be 4. Remember, we're basically foiling this. We'll do it. I'm kind of doing it mentally, but you can always write it out if you would like. So minus 6i over n minus 6i over n. So it'll be minus 12i over n plus 3i over n squared. So plus 9i squared over n squared. That whole thing will be multiplied by 3 over n afterwards. We'll just go to the next line so I don't have to squeeze anything in there. So taking the limit as n goes to infinity of the Riemann sum, so I equals 1 to n. So let's kind of save some work here. So we're going to distribute this 5, or we're not distribute it, but we're going to combine it. So 5 minus 4, and then we'll get a 1 here. So then we're basically going to have 1 times a 3 over n. So 3 over n. And remember this, we're doing minus that. So what's going on in here is you're doing a plus 12i over n, and then a minus 9i squared over n squared. So we're going to distribute that to these terms, but just make sure we get the sign correctly. So it'll be 3 over n times 12i over n. So plus 36i over n squared. 3 over n times this will be negative, will be minus 27 I squared over n cubed. Like so. Let's go ahead, let's break this up. And what we can actually do now is make this into three separate sums. So we'll have, I'll just go next line. I hate squeezing work down on the page. So we'll have the limit as n goes to infinity of these three sums. So we're gonna have the sum of 3 over n plus this sum, 36i over n squared, I equals 1 over n, or I equals 1 to n, minus this sum, 27i squared for n cubed. And so then we're going to basically break these up by using formulas and algebra, of course. So this will be equal to the limit as n goes to infinity. So this just basically takes care of itself. It's just 3 over n times the summation of 1. Now eventually, so will just be equal to n, and we'll do that in the next step. So plus 36 over n squared. Well, we're going to factor that out or take that out. And we're going to have an I left in here. Then we're going to subtract 27 over n cubed. That one looks a little funky. And we'll have an I squared in there left over. So now we can just use our formulas to simplify these three expressions. So we'll have the limit as n goes to infinity. This will just be n. We're just adding one n times, so it'll just be 3n over n. Plus the formula for I is just n times n plus 1 over 2. So it'll be 2n squared. And again, you will have like a formula sheet. You probably aren't expected to memorize those. Minus, and again, we have another expression where we can use a formula, and this will be equal to n times n plus 1 times 2n plus 1 all over 6. So minus 27 n times n plus 1 times 2n plus 1. This is all over 6, so 6n cubed. And let's see if I don't run out of space here. So let's go ahead, let's do some algebra. So this is the fun part, or the funner part. So that'll be just a 3 Here we'll have a 39 or 36n squared over 2n. I like breaking it up now. So 36n all over 2n squared. So that's what this part will be. The parentheses actually don't matter because you're adding anyways. I just like breaking it up now into two separate terms. And here we'll distribute across. Yes, we're gonna need another step here. So 2n squared plus n plus 3n plus 1 all over 6n cubed. Let's see if we can finish it off here. So three. So that those n squares cancel, and that would just be 18. So this will be 18 over n. And here let's go ahead, let's break this into three separate terms. So minus, I'm going to put that all in parentheses. So whoops, distribute that 27n to each of those. So 54n cubed over 6n cubed plus, let's see, 3 times 20, 81 n squared over 6n cubed plus a 27n over 6n squared, or sorry, 6n cubed, I mean. So those cancel. 54 over 6, I believe, is 9, the last time I checked. So I guess 9. This becomes an 81 over 6n. And I believe that'll simplify. They both can be divided by 3, right? 27 over 2n, I believe. If I did my math correct. And that'll just be this will be a 9. They both can be divided by 3, so 9 over 2n squared. But in either case, these don't matter. This doesn't matter because as you go to infinity, this goes to 0, and this goes to 0, and that goes to 0. So essentially, it's going to be 3 plus 18 plus a 0. That would be a 0 minus a 9 minus a 0 minus a 0. So you don't have anything else. So it's just 21 minus 9. And you will get 12. And there you go.